Very good morning, everyone. Welcome to the second session, or you can say second theme of current Sci-Fi. Yeah, I hope you have already have a overall idea of what we are exactly doing. So we already got access to the first set of flashcards, and last class we discussed these flashcards also. So the objective is what the objective of flashcard is to just make your revision process quite a bit of easy, and this is whole done in a mobile friendly format. So it will be better if you are revising it in your mobiles, and if you go for printout, it may not come in the right proportion and all of. If you want printout, you may have to redesign this or realign, do this in A4 size and all. Otherwise, today we have the theme space and astronomy. If you look at the last 5 years papers, I have posted this in the Telegram channel also. If you look at the last 5 years, this is the area where highest number of questions have came. From different astronomical phenomena, we had questions on black hole, quasars, different astronomical projects on missions, Indian missions, foreign missions, matching type of question, conceptual questions. From all different aspects, you are consistently getting questions from these areas. Even if we look at the newspapers, space is becoming more and more relevant, whether it is from economic perspective. Indian space industry, still till far, we have only 2% of global space GDP. Now it is saying by end of 2024, we will be 8% of global GDP. So within a couple of years, we are achieving some kind of a transformative changes in the space sector, with the private sector having more engagement, with defense space sector playing a much bigger role, with more collaboration projects coming up with other countries. So all these aspects, space is going to be in news. It is not like last 5 years you have got now so much of questions and now it may dry up. This is something which is Chandrayaan 3, we have seen Prime Minister playing celebrating it like such a big achievement for India. Anyway, it is a big achievement, but thing is, all this highlights the importance of space sector, and from exam perspective, what is going on in the news, what is going on in the public psych, these topics are given higher weightage. These are taken into exams. Maybe not directly you will get the questions, maybe from conceptual questions you will get, but the importance of space sector is here to stay. So this, what we have done here is majorly the Express and the Hindu. Science Reporter, we have cursively looked and took only very few topics from Science Reporter, you can see. Otherwise, what we have done, we have taken around 140 articles from the Hindu and Indian Express from January 2023 till recent times. Till last 1 week before we have taken the articles. Now we have comprehended this, and earlier if you look at the brochure of the program, what we have told we will be covering space and astronomy under 3 different heads, like astronomical and cosmic phenomena, including all this black holes, star evolution, exoplanets, all this kind. Then we have Indian space missions, which is comprehensive list of Indian programs and all of this. Then we have space missions of other countries. Now we have almost made the material on this regard also. Then yesterday, while I was going through all of this, there was some major lacking in this kind of categorization. Like, even it is science and technology, last class also we have discussed. What we are seeing is question is obviously from developments happening in the recent past. But without having a conceptual clarity on basic things, it is absolutely difficult to tackle this question. You cannot completely rely on your memorization skills. Completely you will memorize everything and handle the questions. That is, even though question paper is factual, that is still exaggerated thinking. What you need is an understanding on conceptual thinking. And if we go with these kind of categorization, the whole focus of our material as well as our class will be on memorizing the things, only understanding the XYZ names that is appearing in the newspaper. And this will like somehow if we integrate this as our final approach, this has high tendency that it will have become a handicap in our whole preparation step. So we have dismantled all these programs and we have divided on the base of different concepts, different themes from science, space and astronomy. Like you can see here from electromagnetic spectrum, that is the most basics. What exactly are you looking out in the space? Then different telescopic technologies. You might have seen different Indian telescopes in Himalayas, in Hanle, in Devastal, in different places, Mount Abu. We have different satellite programs going. So what exactly these satellite programs are looking or telescope programs are looking at. Then exoplanets and planetary system, like developments within the solar system or the other planets regarding it, some discovery is happening, some new phenomenon is happening, all these. Then we have stellar evolution and stellar phenomenon. That means life cycle, basically life cycle of a star, starting from this nebula, then how it is evolving into white dwarf, how it is evolving into neutron star or black hole, all this. Then we have cosmic distance, scale and expansion of universe. This was a topic I thought I should delete it because this is more like a theory. But then there is 2-3 articles published on the Hindu, which itself is based on high technical aspects of this, how this distance between different galaxies are being measured, distance between different stars and Earth is being measured. So if Hindu is covering it in depth or in with the technical language, not even the layman language, so that we cannot avoid it. So light years. That was quite easy questions. But these articles compared to that is not simply light year also. Like technique of how you are measuring this was explained in these articles. So we cannot counter it, we cannot neglect it. Then we have dark matter and particle astrophysics. Particle astrophysics, most basics we have covered in the last class when we discussed about neutrinos, nuclear aspects. So not too much we are going into particle astrophysics, we will be doing with dark matter, dark energy, all these basic concepts. Astrobiology and search for extraterrestrial life. There is a lot of developments, a lot of articles in this regard also. From different biomarkers being observed in different planets, different Saturn moon is having some biomarkers being identified and other exoplanets also identified, presence of CO2, presence of methane, all these kind of things. Then gravitational waves and multi-messenger astronomy. Again, some concept which you should not get away. We had this question on gravitational lensing 2-3 years back. So basics of India also LIGO project is undergoing. So there is high chance a question can come. Then we have the space exploration and human flights, especially of major other countries. Then for Indian major space mission and policies, we have kept a separate difference. So the number of divisions, obviously it has elaborated, but idea is we have not just, if you look at this flashcard material, it is not simply factual collection of current affairs. There is some kind of basics slides also included regarding most of these topics. And once we did these basics, like suppose we are handling with dark energy and dark matter, we have the slides on what exactly is dark energy, dark matter, what are the basic physics associated with this, why this being observed, why it is important. Then we added for 5 recent major studies regarding the dark matter or black hole or all other phenomena. And in this study, if some new concept is coming, that is also being taken up. So that is the whole structure, how we arrange this space and astronomy sector. So let's get started. First part, that is electromagnetic spectrum. Again, one more thing, there is around 183 flashcards in this segment. Very broad segment compared to all other segments. Last class also we have just 100 flashcards. So what we will in class also, it is, I hope you have a basic understanding of all of the things, and many of the part I will skip. I will not explain factual information content. We will explain a little bit of concept. We will explain what things you should not miss. Rest, there will be a lot of factual information within these flashcards. That things you have to read it on yourself. It is not like every single point we will explain. That is not our objective of doing this class also, sessions also. So the first segment we have electromagnetic spectrum and astronomical observations. Let's get started. The first topic. So this is what this is. This is the whole spectrum we are having. So which spectrum, what is the relevance of this spectrum? Last class we have discussed there is 4 fundamental forces. Which are they? Gravity, weak and strong nuclear forces, then electromagnetic force. Now, whenever there is an energy interaction, what happens in the universe? The whole force, every dimensions, these forces get transmitted. In gravity, it is expected to be transmitted like gravitational waves. That means gravitational waves will be transmitted across this space-time fabric. This was the hypothesis given by general theory of relativity by Einstein. Similarly, other forces from weak and strong nuclear force, what is peculiar with them is their range of interaction is very small. But for gravity as well as for this electromagnetic force, their range of interaction is infinite. So gravity, how it is being transmitted, earlier we thought there is no particles associated with gravity. Then we are studying gravitons, all these other antiparticles are being excavated in Large Hadron Collider and all of this. Similarly, for electromagnetic spectrum, that is being transmitted through the particles. Which particle? Photons. The most light photons are being transmitted. Now, depending on energy level, we have n different classification of this. If you look at the fundamentals of this, all these are basically same material, but its energy is completely different. Like radio waves we use in mobile technology. These are non-ionizing, like it passed through us, there is no harm for us. Then that means its energy content is very less. We have this, what is the basic equation? What does this mean? Energy is some kind of an energy, and h is constant, that is Planck's constant, nu is frequency. So with increasing frequency, the energy content of these radiations are increasing. So starting from radio waves, we have very low frequencies of just 10 raised to 3. Then it is being increased. This is not frequency, this is wavelength that is given. Then it is being wavelength keep on decreasing. How much low is the wavelength, that much high is the energy. So with increasing energy is increasing in this direction. You can see frequencies being from 10 raised to 4 to 10 raised to 20 for gamma rays, 10 raised to 4 for radio waves, in that range. Similarly, the frequencies, wavelength will be reducing over this period. Now, what space observation make use of this is, when we look at the sky with the open eye, we will only see what is in this visible range. That's an extremely narrow range within this electromagnetic spectrum. Most of the rays are invisible to human eyes. Most of these rays, including radio, where are we seeing radio waves? You need specialized equipments to see. So what space astronomers does this? They make different satellites, different telescopes, different equipments. Like recently, if you have remembered, there is ExpoSat launched by ISRO in 1st January, right? So ExpoSat, what it is measuring in? It is looking at this world through the eyes of X-rays. Similarly, we have this James Webb telescope. James Webb telescope, major area, it is looking at this universe from this infrared region. Similarly, we have AstroSat. AstroSat is a multi-wavelength observatory. That means it is not just looking at one narrow wavelength. It has different sensors which look at through microwave, infrared, ultraviolet, X-ray, all of these. So that is AstroSat, launched in 2015. Recently, AstroSat 2 project is going on. Date is not scheduled. So this is how we do this space observatory. One more basic concept you should understand: what kind of, from where these rays are coming. That also depends on what kind of event is happening. Like from most of the, like it is not like that gamma rays should come, gamma burst. It is not easy to observe gamma burst in the universe because these are extremely high energy events. When that is happening, then only you can observe these gamma waves. So what kind of events can cause these gamma waves? Like burst of a star, collapse of a black hole. If something like these, or merging of a black hole, if something of this scale is happening, you can observe these gamma rays. Whereas from infrared rays, you might have seen these very colorful images captured by James Webb Telescope. Why these are so much colorful? Because they are capturing the nebulae, that is the clouds they are able to capture. Cloud, you can see, compared to star, black hole, neutron star, all these stars are very high powerful stars. Compared to this, cloud is a low energy base. So if you are capturing the low energy base, you might mostly get low energy radiations. Again, there is a counter to this. It is not strict classification. Even when a merger of black hole is happening, you might get X-ray burst or gamma burst. Along with that, there will be other radiations also. It's not like high energy waves only produce gamma rays. Okay, so this is basic fundamentals. This is some application where we are using this. This is not associated with this astrophysics or observation. Similarly, this is a table which provide where these observations are coming up. Gamma rays, high energy process like supernova explosion, galactic nuclei explosion. Only when these kind of, what is something more powerful than gamma rays? You think of something? गामा का पावरफुल कुछ है? If you include gravitational waves also, then gravitational waves can have higher wavelengths than gamma rays, or you can say higher frequency than gamma waves also. But gravitational waves are not considered a part of electromagnetic spectrum. That's why this is not, we are stopping at these gamma rays. Now this, even if you look, when we discuss this gravitational waves, when we can observe these gravitational waves, exact same thing. There should be some extreme event that is happening. There should be some extreme collapse or explosion or black hole merger. Only in these kind of cases you can observe these gravitational waves. Very similar, you can have correlation with these gamma waves also. Similarly, X-rays you can see in the universe from black holes, neutron stars. Ultraviolet, then you can see the temperatures reducing. Here you can see from hot temperature stars, you can see hot galaxies, you can get so much of UV radiation. Visible light, even our normal stars, normal galaxies. Infrared, you will get from studying cooler objects like planets, dust clouds, star formation objects. This is where James Webb Telescope is working. So that's why it can able to produce very colorful images. Microwave means lesser energy waves. Then radio waves at the latest, at the lowest energy particles. Now this is a brief photo of, here you can see these hot gas from X-rays to different images of multi-wavelength cold gas planets. You can read a little bit about it, not too much actual conceptual content in this. Whatever we have presented here, it's diagrammatic formation you can see. Advances in telescope technology. James Webb Telescope. We have a question on mains from James Webb Telescope of years back, and UPSC has this tendency also 2 year बाद पूछता है कुछ. So, and there is so much news also regarding James Webb Telescope. Every time they are producing some kind of images and it is becoming viral. So it is project by US NASA in collaboration with European Space Agency and Canadian Space Agency, launched in 2021. What is the objective? To observe the first stars and galaxies formed in the Big Bang. Origin of the galaxy study करना यही objective है. Study formation of stars, planetary systems, etc. All these other related things. Which spectrum it is focused on? Primarily on infrared light, but cool down. Yes. But it is have some capabilities near visible and other ranges, but Primary area of interference or primary observation is infrared only. What is the predecessor of this? Hubble Space Telescope. What is the major difference between Hubble and James Webb Telescope? Hubble was mostly visible range telescope. Hubble was rotating around the Earth. It was put at almost all the, you can see the observatory telescopes. They will be placed either in the low Earth orbit. Why in the low Earth orbit? Because there is no considerable advantage going too much into space. Like how much is this atmosphere? 100 kilometers is considered as the limit, Kármán line. So till that means point you will lose almost all the gases and other interferences. So you keep it at 100 kilometer, you keep it at 1000 kilometer, there is no considerable difference you are going to get. So most of the telescopes either you get in these low Earth orbits or you will get in Lagrange points. Lagrange points, this James Webb telescope is in Lagrange point 2, L2 में placed है. Where we have this our Aditya L1 mission. Where it is placed? Aditya L1, the name itself suggests is in Lagrange point 1. So if this is this is what it is. Yeah, we have the sun, we have Earth or a smaller body. It can be with Earth and Moon also. One bigger body, one smaller body. Then there is a line connecting the center of gravities of both. Now directly in between them you have L1 point. That is exactly where this Aditya L1 is placed. Then in the opposite side you get this L2 point. Now you have three different other points, L3, L4 and 1 is other side of the sun. So total 5 from over a 2-body celestial system, you will have 5 Lagrange points. What is specialty of Lagrange point? Okay, so I have a question for you. We have 2 bodies. L1 point, I agree with your stance. I can see Earth is pulling it here, Sun is pulling it there, and that can balance out each other. What about the Lagrange point behind Earth? Both these are pulling in the same direction, so how it is cancelling out? No. 3-body system we are not considering. We are neglecting all other forces, all other bodies coming into. I understand, but we are considering gravities of 2 bodies, Sun and Earth. Normal gravity, Newtonian physics, it pulls towards the center of mass. Now we have a straight line. Sun is here, Earth is here, satellite is here. Sun will be pulling it in this direction. Earth will be pulling it exactly same direction. So where is the balance? One thing you have to understand is yesterday we discussed the centrifugal and centripetal force. So this satellite that is placed in the Lagrange point 2 or Lagrange point 5, they are not sitting there stagnant. They are also rotating around the sun, around the system. Now this rotation will have a centripetal force that is acting towards the center and a centrifugal force that is acting in the opposite direction. This centrifugal force will be balanced by this gravity pull of Earth and the other sun. So both these combined gravitational force will be balanced by the centrifugal force of this rotating body in this point. That's why it is going to go around this. Actually, one more interpretation and for simpler understanding, why this satellite also doesn't require energy, you know, right? We put a satellite in an orbit, it will go on at certain velocities and all this. We calibrated it and put the satellites in the orbit. Then it will go on rotating around the Earth indefinitely. Same thing when it is put in a Lagrange 2 orbit or Lagrange 5 orbit, ideally what is happening is the whole sun and earth is considered as a single system, and the satellite is rotating at the center of mass of this single system. So at Lagrange point and 2 and 5, you can assume this as earth and sun as a single celestial body, and around this is rotating. Exactly what balances a satellite in its orbit, that balancing is exactly happening when when this satellite is kept at Lagrange point 2 or Lagrange point 5. Now there are two more Lagrange points, that is 3 and 4. One is very easy, it is directly cancelling out. 3 and 4 you can understand is whatever you told is correct. In exam also you should look for if there is balancing of these forces, you can take it. But more correct definition is centripetal force required to have this revolution or have this fixed position relative to earth and sun. That centripetal force will be balanced by the gravities of both objects, both celestial bodies. So centripetal force is there, then that is much better definition of this Lagrange point. Otherwise, if centripetal force is not there, balancing out you can take, or you can also take if the option is like a satellite placed there will remain there itself. That is also a definition of Lagrange point. You put a satellite in Lagrange point, it will remain relative to earth, it will remain there only every time. Now there is so much minute details on this, what is James Webb telescope, you can see. Rest of the information you can read from these flashcards. Let's move into the next topic, that is Webb captures hamburger that is first detailed picture of ice in planet forming disk. These all are different observations done by James Webb telescope. There is two-dimensional ice inventory, like importance of ice in planet formation, all these things are discussed by HH48NE, that is representing this protoplanet, you can say protoplanetary disk, all these the picture. Event Horizon Telescope. Which country is this, or which agencies launched this? EU or European Space Agency. Now, whenever you hear this Event Horizon Telescope, that is not meaning a one single telescope. That is a series of telescopes, and its combined data is used for observation. What is the major, most, you can say, highlighted contribution of this Event Horizon Telescope? That is the black holes image was created 4 years back, 2019, I guess. So that was created from the observations, from the data we got from this Event Horizon Telescope. This is still functioning, still in use. Which spectrum it is looking at? It is looking at the radio wavelength spectrum. So these are the areas you can see telescopes being put, and it is combinedly acting as a single telescope. The data for all these points are combined together. This is the first image of black hole we have created. Reason, this is not the most latest image. Latest image you can see more refined one image is created in later. Those in 2019 were the first image was created. Now what Event Horizon Telescope recently done is it captured the first image of Sagittarius A. What is Sagittarius A? Black hole at the center of Milky Way. That is our galaxy center is also having a black hole, and that exact black hole is called as Sagittarius A. Lot of factual information, how much distance, what all are its size, all this you can read from your flashcards. This is another information, that is Meerkat Radio Telescope array in South Africa. You might have seen this image where a field is there and hundreds of mirrors or satellite antennas are kept. So that exactly is a picture from this Meerkat Radio Telescope array. A lot of telescope will be kept in a field, and everyone will be focusing on some kind of burst So it have reported a first radio burst, FRB. Now these are other XYZ details about this. It will be also looking at these radio frequency ranges. Already it is a radio burst being observed. Rest other you can read it from here. Aditya L1, that is Indian Observatory. Aditya L1 is not directly looking at the space, it is specifically looking at the sun. Why it is kept in Lagrange point? Because if it is kept in around the earth, then at some point earth will interfere with this observation. If it is kept in Lagrange point, then it will have complete clear view of the sun throughout the cycle. Secondly, something which is kept in Lagrange point, it will stay there. It doesn't need extra set of energy or anything. So these are the major reasons why it is kept in Lagrange point. Then objective is to study the solar wind, sun's chromosphere, corona. What is speciality of corona? What we see sun as circle is what it is called, it is photosphere of the sun. Now it is this edge of the sun's temperature, what we say. Like usual sun's temperature is lakhs of degree, lakhs of Kelvin, lakhs of degree Celsius. That is at the core of the sun. But in the photosphere, it is having a very low temperature of 5600 degrees Celsius, 5600 Kelvin. 5600 you can even relate with at the center of the earth, we have a comparable temperature ranges. But corona is a gas area that is outside the photosphere. And what we observe is this corona region is having extremely high temperature compared to the region that is photosphere of the sun. So this is a very strange phenomenon. Usually what we observe is temperature should gradually reduce. So more distant from the core of the sun, we expect it to be lesser temperature. But here we have a reverse phenomenon that is happening. Photosphere is the lowest temperature part in this whole sun dynamics, and outside sun corona gas is having very high temperature. And there is no consensus on what mechanism is working, what exact mechanism is making heating up this corona region to this high degree. So these all of these. Then we have the solar wind. Solar, if you look at the solar wind, recently also James Webb telescope, when it was launched, its mirrors have been destroyed. Some mirrors has been destroyed by this solar wind. There has been need for certain repairment, all of this. Solar wind is, it is very important to have a idea on this. For all the satellites, impacts telecommunication, it gives a picture on the different phenomenon that is happening. So all these things within the sun is being studied by Aditya L1 mission. First factual information, it is placed at L1 orbit, which is roughly 1.5 million kilometers away from the earth. It will be looking at is visible ultraviolet and X-ray. That means the multi-wavelength observatory, not a narrow wavelength observatory. These are all other different aspects related to this. You can see how it is going like this. Then it is being transferred to the L1 point. Different factors